So now let me read the problem. So now let us see this problem. What would be the final temperature of a maximum mixture of 50 grams of water at 20 degrees Celsius and temperature and 50 grams of water at 40 degrees Celsius temperature, right? So what is the given data? Let's write the given data first, right? So what is that? 50 grams of water at 20 degrees Celsius, m1 is equals to 50 grams and t1 is equals to 20 degrees Celsius, right? And at the same time, what one more thing, 50 grams of water at 40 degrees Celsius temperature, right? So another substance also same, 50 grams of water at how much temperature it is, 40 degrees Celsius, right? So 40 degree Celsius. Now let us solve. Yesterday we have derived one equation. What is that? Final temperature is equals to S1 M1 T1 plus S2 M2 T2 by S1 M1 plus S2 M2. This is the right, this is the equation that we have learned, but to remember that they both are same substances, so the specific heat is same, then the formula becomes like m1 t1 plus m2 t2 by m1 plus m2, so that t is equals to m1 in the sense 50 into t1 in the sense 20 plus 50 into t2 in the sense 40 by 50 plus 50, right? So now we'll now let me solve here. Then final temperature will be, if you take 50 common, then what happens? 20 plus 40 by 100, 15 this 2 times, so final temperature will be 60 by 2, that is equals to 30 degrees Celsius. This is the answer for this formula, right? So this formula useful for all the substances, for at all mixtures, right? Next, coming to let us solve similar problems. So before solving those problems, let me explain the behavior of water. Behavior of water when we try to heat, right? So here in this case, what we'll do is we'll take ice cubes in a bowl and a thermometer, a beaker, not in the bowl, we'll take a beaker. In the beaker we'll take ice cubes, right? Let's think there is a beaker with a ice cubes, and it's a temperature. To measure the temperature we need to use thermometer, right? So in the starting, when you start this experiment, the temperature of the ice cubes will be like minus 10 degrees Celsius or minus 20 degrees Celsius, whatever it may be, right? But the temperature would be in the minus, right? So here we have taken a beaker and the ice cubes, and we tried to measure the, by using digital thermometer you can measure it, right? So now here the temperature of ice cubes are like minus 5 degrees Celsius. Now what we have started is, we started giving heat to the ice balls. Very simple, we are just heating it, that's it. Now here when you are heating, then what happens? Guess it. As the heat energy is rising, as they are observing heat energy, their temperature also gets raised, right? So here if you observe in the starting, the temperature will be very low. When they are observing heat energy, the temperature rises, right? Here as I am giving heat energy, the temperature rises to, let me explain this in the form of graph, right? Here on x-axis I will represent the time, on y-axis I will represent the temperature, right? So now here as I am heating, the temperature from minus to 0, it increases. The temperature increases to minus 5 degrees Celsius to 0 degrees Celsius. After reaching the 0 degrees Celsius, I'm continuously giving heat energy, right? So after reaching to the 0 degrees Celsius, as I observe, the rise in the temperature stopped. Means there is no change in its temperature. It stopped at 0 degrees Celsius. Then I got doubt and I observed the substance, ice cubes. then when the temperature reached to the from minus degree Celsius to 0, I have observed that all the ice cubes started to melt. They started to melt, right? So now here then I am continuously giving heat energy. As I am continuously giving heat energy, the ice cubes started to melt at 0 degree Celsius. At minus 5 degrees Celsius they did not melt, right? After reaching their temperature to 0 degree Celsius they started to melt, and I am continuously giving heat energy. After a certain time, what happened? All the ice cubes were melted. So the substance became a liquid, but the temperature is 0 degree Celsius itself. That means in the starting from A to B there is a rise in temperature. After some time there is no rise in the temperature, just it is constant B to C. But here what happened? All the solid means ice cubes converted into liquid stage. That means here the melting is taking place. What is the meaning of melting? The process of converting solid into liquid at a constant temperature is called melting. If you observe this experiment here, until ice cubes melt, there is no change in the energy, I mean temperature, right? So that is the definition will tell. What is the definition of the melting? The process of converting solid into liquid at constant temperature is called melting, right? After melting all the ice cubes, the total substance turned into liquid form. After forming into liquid, then what happens again? Then I observed a rise in the temperature. The temperature rises to 10 degrees Celsius. Continues it is rising until 100 degrees Celsius after melting, right? So let me take this point as a D. After reaching to the 100 degrees Celsius, again I observed that, I mean let me imagine that it is a closed container, right? So after rising to the 100 degrees Celsius, then what happened? Again I found that there is no further rise in the temperature. Again I observed the substance carefully, then I found that all the liquid started to convert into gaseous stage, right? So after certain time the temperature was constant until after certain time. What happened? Until the total liquid converts into gaseous stage, the temperature were constant. After converting total liquid into gaseous stage, then again I found the rise in the temperature in gaseous form, right? Here at the stage D2E there is no rise in the temperature of the substance, but the substance is converting into liquid stage to gaseous stage, right? Here exactly this stage is called boiling point. What is the meaning of boiling point? The process of converting liquid into gaseous stage at a constant temperature. The temperature is not increasing as long as boiling is taking place. After completion of the boiling stage, the temperature starts rising again, right? So here based on this graph there will be many questions in your public examination. First question will be what is, where do you find a liquid and a gas solid state in this situation? Exactly we can find in the situation BC. We can find solid and liquid in the situation BC. What happens at BC? Melting takes place. Melting in the sense the process of converting solid into liquid. So in the position of BC you can find solid as well as liquid, but in this situation the temperature will be constant, right? Again after C to D, the substance you can found the substance in only liquid form. In A to B you can found substance in a solid form. B to C solid plus liquid. D to E you can find liquid plus gaseous state, because DE is the point where the substance get boiled, right? So in this stage you can find both liquid and gaseous state. After E you can find only gaseous state, right? This is about the behavior of water at different temperature levels, right? Based on this we are going to solve many problems. I'll tell you only one problem. If you'll understand this, you can easily solve all the problems based on this content, right? So here uh, B2C is called melting. At constant temperature, the process of converting solid into liquid is called melting. So opposite to the melting, can you guess? Freezing. The process of converting liquid into solid is called freezing at a constant temperature. That means here, when the substance is converting from solid to liquid, it is absorbing heat energy. At the same time, while the substance converts liquid to gaseous state, then what happens? It releases heat energy, right? By absorbing heat energy, the solid is converting into liquid. In the same manner, by while releasing the heat energy, the liquid converts into solid. So melting, freezing, both are happening at constant temperature. And next, if you see, the stage D is called boiling point. So boiling point, in the sense, here the process of converting liquid into gas at constant temperature is called boiling. In this stage temperature is constant, the liquid is converting into gaseous, right? What about its opposite process? The opposite to the boiling point is called liquefaction. So here in the liquefaction, you can find that at constant temperature the gases will convert into liquid state, right? So these are the main things to solve. And we have done as graph, right? Let's explain a few more terms also. The first one is evaporation. Actually, the process of converting liquid into gases at constant temperature is called boiling. But what about any temperature? For example, if you pour some water on the floor, after some time, what would happen? The water gets evaporated. That means the liquid will convert into gaseous state. Does anyone give heat energy to 100 degrees Celsius there to change? No, no one, right? Here what is happening? Evaporation. At any temperature, water can convert into liquid state to gaseous state. That process is called evaporation. It may happen at any temperature, not at constant temperature. Do remember that. And next, after that, if you take converting into liquid, gaseous to liquid, right? At constant temperature, if gas convert into liquid form, then it is called liquefaction. If the same thing happens at any temperature, then it is called condensation, right? So when you take a glass and if you pour cool water or a cool drink in this glass, you can find very tiny droplet around the glass, because the water vapor, the gaseous water vapor in the air, when they touch the glass, then the heat energy from the water vapor will be absorbed by the cool drink, and then what happens? The water vapor turned into liquid form. At any temperature it happens. That is why condensation. Understood, right? So coming to evaporation, what does evaporation, how does this process will take place? In evaporation, if you observe carefully, if you take a bowl water, there are many layers of water, many layers of liquid. Upper layer liquid particles, they'll absorb heat energy from the lower level liquid particles and they'll fly off from the surface. So that is why this is the reason why evaporation takes place. So that is why evaporation is a cooling process. Condensation is warming process. Hope it is very clear, right? So how the evaporation takes place? The upper layer surface layer molecules, what they'll do? They'll take energy from the down layer particles. They collide each other. While colliding, the heat energy will be generated. That energy will be absorbed by the top layer molecules, and they'll, with that energy, they fly off from the surface, right? So there is a one more question on evaporation. 8 more questions. There is a chance to ask 8 more question. It's a surface phenomena. If the surface is more molecules will fly off. If surface is less molecules will fly off. Clear? For that also very experiment is there in our textbook. we can go through that. If you want clear information about that, you can ask me, right? And after condensation, right? Hope both are very. Now, let me give one more example. When you take nail polish, at the time you feel very cool to your finger, because when you apply spirit to your hand, the molecules in the nail polish absorb the heat energy from your hand, they'll fly off. So evaporation is cooling process. Dog pants in the summer days, because dog don't have sweating glands in his body, so it has only few areas like toy and legs toys and nose, that's it. So to decrease the body, it keeps the tongue out, and it tries to leave the heat by using that, because the water on the tongue will get evaporate. So when the water evaporates, the body gets cool. So because evaporation is a cooling process, right? Like this, it will be more. And after this, yeah, I'll make separate video for the main problems in the heat energy. Hope it's very clear. Thank you for watching more. Thank you for subscribing. Have a great day.